elements we wanted to highlight today is the success of electric vehicles is going to be based on making sure that we do not compromise the performance or the attributes that the consumer is looking for, and that's exactly what we are doing. An example that it is part of powertrain, but it's not, it's part of the structure of the vehicle, is the battery tray. This is a technology that we're able to deploy in steel, in aluminum, or in composite material, depending on the application. And it depends on the trade-offs between many attributes in the vehicle. Working with an OEM or with a customer, we're able to do and tailor the battery to what fits within that vehicle. ADAS, or driver assist technology, is something that Magna has been spending a lot of time on for current production. As we know, there's a significant growth in driver assist technologies, but there's also opportunities to improve efficiency using the technology. So what you see on the screen is radars, lidars, ultrasonics, cameras, and domains for a full system that Magna is using the building block approach to build that capability in today's vehicles, and it would apply directly into electric vehicles. Aero is another area that is very key to improving efficiency, and there's static and then there's dynamic arrows, and Magna is involved in both. And we're very proud to save a lot of energy use today in production programs, and that will continue into the future with dynamic aero, including the entire efficiency of the vehicle. And just to highlight that with the capabilities that we have around the full vehicle, we are able to understand what areas to target to improve efficiency through aero actions. Talking about full vehicles, Magna is capable of both engineering and manufacturing full vehicles. When we talk about electrification and electric vehicles, there are a lot of examples, including what you see on the screen. We manufacture the Jaguar I-Pace and E-Pace in Europe on the same production line, which gives us the opportunity to understand the non-electric plus the electric variation, how to improve the manufacturing process. From an engineering standpoint, we have engineered the Sony Vision S, which was introduced last year at CES. And recently we announced that we are working with Fisker to engineer with the Magna EV platform and produce the Fisker Ocean for production. With the building block approach, Magna realizes that this is not something that we would do all ourselves, but partnerships become very critical, and integration of a lot of the technology is critical. What you see on the screen are examples that some we will talk about today, like LG Electronics for electrification, and some on the right-hand side, for example, with Innoviz and Under, where we are collaborating on the technology to produce and engineer driver assist technologies with the right sensors, as well as full vehicle, as you could see on the bottom left-hand side. So the building block approach is one of the things that we pride ourselves in doing, both on the technology, the engineering, and the manufacturing. And with that, I'd like to turn it over to Ron to talk more about the powertrain.
Well, thank you, Sharif, and hello, everyone. My name is Ron Farley. I'm responsible for strategy in Magna's Powertrain Group. Today, I'd like to give you a brief overview of our powertrain electrification strategy. I'll start by talking about traditional powertrain architectures. You know, it really wasn't that long ago that we as consumers, when we went to purchase a passenger car or pickup truck, our choices for powertrain systems were relatively limited to traditional powertrains. We had choices in internal combustion engines for either gasoline or diesel engines. In terms of an automatic, or in terms of transmissions, we had basically 3 different types of automatics or a manual transmission that we can choose from. And then there are additional options that you can specify for performance, driving dynamics, safety, things like four-wheel drive, all-wheel drive systems, for example. In these traditional powertrains, the internal combustion engine is the power variant. We see engines from 3 cylinders all the way up to 12 cylinders, ancillary devices like turbochargers that bring power variation to the system. But essentially, maybe 8 or 10 different basic powertrain configurations that are in the marketplace in the traditional space. I think we all know what's happening in our industry today is a pretty significant reduction to the powertrain. Essentially, legislation is driving that disruption. It's legislation aimed at improving air quality in the interest of improving human health, as well as reducing CO2, which is harmful to the environment. These two things are byproducts of internal combustion engines when they're operating. What you see on the slide now is Magna's forecast for powertrain systems in 2030. So really only about 9 years away from where we are today. And what you see on the one side, the red and the gold area, are those traditional powertrains that I just talked about. And then in the blue pie sections are all the electrified powertrain systems, which, as you can see, represent more than 50% of the powertrains in vehicles sold in 2030 per our forecast. So when we talk about powertrain systems, what I would say is that today we're in a transitional period. That being said, as a powertrain company, Magna has to continue to provide traditional powertrain systems to our OEM customers, while at the same time transitioning to electrified powertrain systems. This brings a lot of complexity and proliferation into the picture. So starting with architectures, hybrid electric, plug-in hybrid, and electric vehicle architectures are coming to the marketplace. Here we add an e-motor to the powertrain to augment the internal combustion engine in the interest of reducing tailpipe emissions, or by the time we get to a full battery electric vehicle, then the internal combustion engine is gone. Those e-motors can be positioned really in 5 different places in the vehicle, everywhere from the accessory drive, which is like a belt starter generator, right out to an axle drive or even a wheel end drive. So the motors can appear all over the place in the vehicle. And then there is still a desire for performance enhancing features, safety enhancing features, and the advent of electric four-wheel drive and electric all-wheel drive systems come into play as well. And this means that many vehicles on the road will have more than one e-motor and one inverter, more than one powertrain system, electric powertrain system within those vehicles. So a lot of complexity being added, a lot of proliferation. To add to that, the e-motors come in a wide variety of power classes. We're seeing requests for power levels as low as 15 kilowatts all the way up to 250 kilowatts of power. In some cases recently, even as high as 300 kilowatts. The e-motors operate at various voltage ranges from 48 volts all the way up to 800 volts. So all of this brings a significant proliferation. In addition to the, let's say, 8 to 10 traditional powertrain systems, we're seeing as many as 40 additional powertrain configurations that are being asked of us by our OEM customers. I should also mention that the e-motor and inverter become very significant in the composition of an electric powertrain system. So in a traditional powertrain system, they're non-existent, no value add, but in an e-drive system, as much as 70% of the value add comes from that e-motor and inverter. And so we have that facing us as well. And so our approach to dealing with all this complexity is to leverage scalable building blocks. Sharif talked about the building block concept at the vehicle level. In the powertrain group, we also have a set of building blocks. And here you see our 12 building blocks that we use to produce both our traditional and electrified products. 9 of those building blocks are shown in red. We've used those to build our traditional systems like four-wheel drive transfer cases, all-wheel drive products, and dual clutch transmissions. We are the global leader, independent supplier of four-wheel drive, all-wheel drive systems and transmissions in the marketplace today. So we have a large portfolio of red building blocks for traditional products. When you want to electrify those powertrain systems, either to make a hybrid transmission or a complete electric drive system, you need that e-motor and an inverter, as well as software and controls. I'll talk a little bit about software and controls, only to say that they become increasingly important in these electrified powertrain systems as the vehicle of the future, the car of the future, becomes more and more automated with advanced driver systems. Full autonomous vehicles, you need to be able to control the powertrain system. Our experience on the traditional products in terms of not only building systems, integrating systems with the mechanical building blocks, but also developing and providing software for full functional control of those systems is important to us in that space as well. So in the end, we put these building blocks together, and our objective is to provide our OEM customers with powertrain systems, everything from traditional systems all the way to pure battery electric powertrain systems that bring our OEM customers best-in-class performance in efficiency, safety, dynamics, and convenience. We've been producing at Magna Powertrain electric powertrain systems for quite some time. We started with our first full powertrain system, electric powertrain system, with the Ford Focus battery electric vehicle back in 2012. So we have the capability to design and develop those systems, as well as to produce e-motors and inverters as well. But one of the things we realized, if you think back to that slide I showed with all the configurations in e-motors and inverters that our OEM customers are asking us for, we did not have a portfolio of motors and inverters developed on the shelf to use when building powertrain systems. So we felt it was important for us to find a partner who had e-motors and inverters on the shelf that we could leverage for our powertrain systems, as well as a partner who had experience in high volume manufacturing of those building blocks. And for that part of the story, I'd like to turn over now to my colleague, James Tobin. James is the Senior Director of Business Development in our powertrain group. James?
Thanks, Ron. I would like to briefly introduce our strategic approach to our partnerships in the electrification market. Our expertise at Magna is supplying power to the wheels, and our strategy is to be at the forefront of electrification, supporting automakers with a diverse and world-class product portfolio. As you've seen, last year in December, we announced a partnership with LG. This partnership aligns with being at the forefront of electrification, supporting our traditional automakers and also being able to support new energy vehicle manufacturers as they enter the market. Magna and LG are leaders in their respective markets, and we expect to gain investment efficiency, speed to market in this transaction, with synergies to achieve more. All will continue to capitalize on the acceleration of the electrified powertrain market. We both will capitalize on an electric market that is essential for both parties, as we can supply e-drive components to the joint venture or supply e-mobility systems depending on customer needs. Utilizing, as Ron mentioned, a scalable building block approach to powertrain systems, it enables automakers and new entrants to leverage common platforms regardless of what their take rate is. By coming together with LG, we can offer individual components, e-motors, inverters, and onboard chargers, all the way through electrified powertrain systems. This union allows for growth for both partners. It accelerates Magna's time to market by utilizing LG's footprint in South Korea and China for manufacturing, accelerates Magna's software, mechanical products, and system integration, which add tremendous value to this venture. We expect this joint venture to close in the second quarter of this year. But for those of you who follow Magna, this is just the latest development in our electrification journey. We supplied our first electrified powertrain system in 2012, as Ron mentioned. Following several other firsts, in 2017, we entered into a joint venture with Huayu Automotive Systems, a subsidiary of SAIC Motor, and with this, expanded our electrified powertrain offerings with a dedicated footprint in China. This joint venture is focused on e-drive systems, and we're excited in this past November to announce that we launched our first serial production high voltage e-drive system at Hasco Magna Electric Drive Systems, our facility in Shanghai. As you can see, this complements our existing range of products, including hybrid transmissions. And you can see our portfolio is expansive and definitely future ready to capture all the opportunities within the changing global legislation. With more than half of the world's vehicles in 2030 having an electrified powertrain, in the future, we will be able to improve fuel efficiency, reduce emissions, and improve air quality, all while not sacrificing driving dynamics or performance. At Magna, we are excited about the electrification future. not just with us, but with our JV partners, Hasco and LG. As Ron mentioned, we're going to follow a building approach that puts us at the forefront of powertrain engineering, design, and manufacturing. Not only do we supply everything from an individual component to a complete powertrain system, but as you heard from Sharif, we also assemble electric vehicles too. Finally, Magna is proud to be recognized as an honoree in this year's CES Innovation Awards for 2 products, our EDS Mid Plus eDrive and our eTelligent all-wheel drive. Both of these represent our latest technologies in achieving best-in-class performance, efficiency, safety, drivability, all for electrified vehicles. Thank you very much for your attention today. I would now like to pass it over to Rhiannon to moderate any questions we have received from the CES community. Thank you.
Hi, everybody. Hi, everyone, and thanks, James and Ron and Sharif. So let's get going with our first question here. James, here's one for you. When will the JV with LG start to manufacture those motors and inverters?
Great question. As you can probably imagine, one of the advantageous portions of partnering with LG is they had an existing product portfolio to pick from. So today, they're already manufacturing at high volumes, e-motors and inverters at their plants in South Korea and China. And we expect jointly for this joint venture to close where it's a combination of efforts, but they're already in production today, which is a great for our building block approach to electrification.
Great, thanks, James. Next question again for you regarding the joint venture. At which Magna development sites will the joint venture be installed? In other words, which Magna sites will participate in this joint venture?
Yeah, so we'll look at a global approach based on customer needs and wants. Obviously, the joint venture is going to focus primarily on electrification components, and then based on specific needs, we'll incorporate our global footprint as Magna to be able to attack global systems as customers come through the product portfolio.
Great, thanks you. Next one again for you. Where will the new joint venture be headquartered?
The headquarters will be in Incheon, South Korea.
Great, thanks. And next one's for you, Ron. Again, going back to our building block discussion, can you give me an example of where you would use existing LG building blocks to develop a complete powertrain system?
That's a great question, Rhiannon. So maybe a good example, if I go back to the introduction that Sharif gave, where he was highlighting the e-powertrain systems for a pickup truck. One of those products that was shown there was an electric beam axle that we're designing and developing today. And we had a target power of about 250 kilowatts for that particular e-beam axle with a very tight packaging space. 250 kilowatt e-motor is not something that we had in our portfolio of building blocks on the shelf that we could pick from. Whereas with LG, they do have that product available, both motor and inverter, and we could pull from our JV partner and then select those building blocks and build them into that product, saving lead time, resources, cost, both in terms of development of the product, but as well as industrialization.
Perfect. Thank you, Ron. Another one here about the LG joint venture. Great questions, everybody. Again, back to you, James. How many OEMs could be customers for this joint venture with LG?
Great question. LG's got a solidified base that we've put together. They supply GM and JLR and more today, and we would look to only expand that as they grow. They have various customers that have booked orders today, and obviously with Magna's global customer reach, we would also like to attach that to the portfolio, including not limited to going after new energy vehicle manufacturers that are entering the market for strategic reasons.
Great, thanks again. And then one more question, again, staying with you, James. By doing this joint venture, what are the key indicators for leveraging this venture? So what are the main advantages to Magna and to LG?
Yeah, great question. I think if you go back to Ron's presentation, when you look at a building block approach, we see, significant elements from our traditional business that crosses over into the electrified market. But when Ron said 70% of the E-system cost could be built up of an E-motor and an inverter, having a vertical integration aspects of that into our portfolio is key for us moving forward. So we believe not only having the scale that LG brings to the table, but the access to vertical integration opportunities is going to be critical for Magna to be successful in the electrification market.
Great, thank you. Ron, next one's for you here. What are Magna's plans for hybrid integration? Could you answer that one for us?
Sure, another great question. So from a hybrid perspective, I would say our building block product, we use a scalable approach in products as well as in the building blocks that build them. So our base transmission being a DCT, 7-speed DCT transmission that was designed from day one to be scalable to both a 48-volt mild hybrid as well as a high voltage hybrid or even plug-in hybrid. So what that offers to our OEM customers is in a front wheel drive vehicle, the ability to offer the customer either a standard traditional powertrain system, a mild hybrid, all the way up to a plug-in hybrid architecture, all fitting within the same space between the wheels of the passenger car. So that's a huge advantage to the OEM customers to be able to do that. As well, our history and legacy in four-wheel drive, all-wheel drive systems, where we're the global leader today of an independent supplier of those systems, to be able to take these electric drive systems and offer them as a secondary axle in a vehicle, as an E all-wheel drive or E four-wheel drive, let's say in a plug-in configuration. So a front-wheel drive car with a traditional powertrain and one of our electric axle systems in the rear would be marketed as let's say a plug-in hybrid where the electric axle can operate completely independently from that front powertrain system.
Great, and then a quickly related question here for you, Ron. What is Magna's role in PHEV integration?
So again, we work with our OEM customers. When you have especially if it's a PHEV, let's say it's an all-wheel drive where you have two powertrain systems, you've got two completely independent powertrain systems that have to operate sometimes independently, sometimes together. And so that controls and software operation becomes very, very key. And we work very closely with our OEM customers to provide software and functional software for the eDrive system, let's say, and to make sure it operates properly and seamlessly with the traditional powertrain system in a vehicle.
Thank you. Sharif, over to you for a couple of questions here. I believe Magna was there in ADAS since the past 2 decades. Are there any insights for AI, ML, DL in autonomy or electric from Magna?
Yeah, the way, technically the two don't need to tie together. However, we see a lot of growth in ADAS just in the last 2-3 years, and of course in the past decades. To the extent that we've seen in automotive some significant features that have gone from optional to standard. Most people now are used to things like lane keeping and adaptive cruise and city stop and things like that. And in electric vehicles, the difference is technically there may not be too much difference, but the customer expectation in an electric vehicle is it comes with all the bells and whistles. It comes with all the technology and ADAS all the way. I mean, we could talk about level 1, 2, 3, and then level 4, 5 in the future. Those are all technologies that the EV customer is expecting because they tend to be more technology savvy, more ready to accept technology. In addition to being able, as an industry, we have to be ready to launch hardware and then bring in the software and the updates through over-the-air updates and things like that in the future. So definitely the customer expectation is higher, and we do expect to see more adaptation to ADAS in electric vehicle than what we've seen even in the past.
Great, thank you, Sharif. Another question here for you. Can you talk a little bit more about the platform that we used for the Fisker Ocean? And where do things stand in terms of having other EV wannabes also sign up to use this platform?
Yeah, for Fisker, both the mechanical platform and the electrical platform, we can call it electrical architecture, we can call it ADAS portion, which was a recent release that we had, comes from Magna, but it's a very strong collaboration between Magna and Fisker because it has to work for the end consumer. And the Fisker obviously has certain expectations from the customer standpoint. Magna has the experience in automotive and in the platform development. And one of the nice things about the platform is there's obvious reuse that happens within an OEM, and then Magna as an independent supplier can spread that across multiple usages. So the question about other users is very appropriate. And yes, there are a lot of people that are interested in reusing the platform. We can't talk about collaborations or agreements until they happen, but those discussions are ongoing.
Great, thank you, Sharif. I believe our time is running out here. So what I would do, we have received a lot of questions. I would encourage everybody to come and visit the Magna experience here at CES and talk to one of our technical experts where you can get all the rest of your questions answered. With that, I'd like to thank everybody for joining the Spotlight and have a great rest of the day and enjoy your CES digital experience. Goodbye.